Hi everyone, welcome back. So this is just another video in this series where I am talking about the use of the R programming language and RStudio for data science tasks and for data analysis. Okay, so in the previous video I started talking about data types in R, and we looked at a built-in data set and we talked about how to convert a string or character variable to a categorical variable, and how you can, if you have a variable that should be numeric but it's been imported wrongly or something like that as a string, how you can convert that to a numeric variable. So what I'm going to do is I'm going to build on that a little bit more. So we're still covering these really basic foundational concepts in using R, and talk a little bit more about the most common data types that are used in R. So we've already covered a few. Those were like double precision, which were decimals, floating point numbers, or numeric variables or data types, integers and characters. But we'll go over those again here and talk about a couple of others as well. So the 5 most common data types that are used in R are numeric, which is the set of all real numbers. If they're decimal numbers, they're referred to as float. They what are in other programming languages such as Python referred to as floating point numbers. They're referred to as double precision numbers. In addition to that, we've got integers. That's another data type commonly encountered when using R, and that's the set of all integers, Z, or round numbers. Then we've got logical or Boolean data types, Boolean operators that return either a true or false value so for when a statement's true or it's false, and those are referred to as logical. And then we've got complex numbers, so you can actually work with complex numbers using the R programming language, and the complex numbers in R recognized as its own data type, and it's the set. It covers the set of all complex numbers. So you've usually, for a complex number, you usually see it written as I've got in parentheses here. So you've got the real number part, such as 1 plus an imaginary number part. Okay, for anyone who's never seen a complex number before, you usually see it something like that. So a real number, in this case 1 plus the imaginary part, which is 2 times I. The I it's there to signify that that's the imaginary part of the complex number. Okay, and then we've also encountered them in the previous video. We've also got character variables, which are strings or text variables in R. Okay, so let's just have a look at a few of these. I've already got this script kind of set up with a few different things. So let's talk about numeric first. So I can create an object. I'll call it X, and I'm using this assignment operator, the less than and minus. The keyboard shortcut for which is Alt minus. And I'm assigning the value 4.5. Okay, so it's a decimal number. If I run this line, you will see in values here in our environment, we've now got a value X, an object X, and it's got a value of 4.5. And we ask what class of data this is, what the data type for this. It returns numeric. Another method or function or command we can use when we're trying to figure out what sort of data types we're working with is this command type of. So we put type of, and then we just put the object that we're interested in, the variable that we're interested in parentheses. And if I run that command, you can see in the output window below in the command line that it returns double. So that is the double precision, because this was a decimal number, it was a floating point number. In R, it's referred to as a double precision value. Okay, so it's we've got a double precision numeric variable there, which is saved as that object X. So let's look at integers next. So that's obviously round numbers, so whole numbers. So let's create an object called Y, which is just a container holding the value, one element, the value 5. So if I run this, we've assigned 5 to this object Y, and if we look at the class of Y, it'll return numeric. Okay, so integers are numeric variables, so that's completely, it makes sense. But if we run the type of command, you'll find that what it's done is it's returned a double precision. So it's treated, although we kind of wanted it to be an integer, it's returned it as kind of a decimal. So 5.0 essentially is what it's kind of treating this as. But if we could work with it like that, that's absolutely fine. But we can convert it to an integer if it's essential that it is an integer value or an integer data type that we need it to be. But what we found here is that just kind of like creating this object here, it's created a numeric variable that's saved as a more precise kind of numeric variable. But let's use this as.integer method on y that we created above to convert that to a integer. So I'm just overwriting the value y with this command as.integer. If I run that, you'll see something interesting in the environment here. You see y now got a 5 and this L next to it. And if we run class for y, it tells us now that it's an integer. And if we do type of, we'll get the same thing. It's recognizing this as purely an integer. It now returns the correct data type that we're interested in. But an alternative way we could have declared this to be an integer would have been if we'd have just, when we created it, we could have appended this L as a suffix to it. So let's do that here. We'll create another variable called Z. Let's use a different value other than 5. Let's use 6 so it'll appear different here. But so I'm creating this object Z. It contains only one element, and that's the value 6, and I want it to be an integer, so I put 6 and an L next to it. Okay, and if I run that, you can see it appears as 6L there, and if I ask for the class, you can see, and the type of, you can see it returns integer for both. So what we've done there is declared that it is an integer from the start just by appending this suffix of L next to it. Okay, so that's integers. What about complex numbers? I mean, it's not often going to be the case that you're working with complex numbers unless you're doing some quite advanced maths, I guess. But we can declare a complex number by specifying it in the way that you would any number, by adding the real part and the imaginary part. So let's create this object A and set it equal to, I could have noticed here that I've used the equal sign rather than the assignment operator there, the minus, the less than minus kind of, it's like a backwards arrow assignment operator. That's probably bad form, you know, in art. Usually when people assign values to things, they usually use the other, but you can do it, as I said in a previous video, you can use the equal sign, which is usually used as it's commonly used as an operator in other programming languages such as Python. So let's create this complex number. So if I run that, we should get an A. Yeah, we get an A now in our environment here. It says 4 plus 3i. Well, let's ask what the class of data this is. And you can see it recognizes it straight away as a complex number. And if we do type of as well, also shown as complex. So we've created a complex number. Okay, so a couple more. Logical, remember this was the Boolean true and false values, which are commonly used when you're doing logical stuff in computing. They're very useful for checking certain things. So let's create a new, I've chosen different kind of like letters of the alphabet here, just so we're not writing over the other ones. But let's create a new object called B and set it equal to whether y is greater than x. So remember we created y and x here. So y is the integer 5, x is the kind of number 4.5. So 5 is greater than 4.5. So if I run this, you can see it runs below, and if you look in the environment here, the value associated with B is true, because it is true that 5 is a larger number than 4.5. Okay, so if we look at the class of B, it's shown as logical and also type of shown as logical. So it's kind of it's different really. It's like here we've created an object which is a true statement based on the fact that 5 is a higher value than 4.5. Okay, it's not, we've not created we've assigned B using this inequality here. We've not created an equation or anything like that. Okay, so we've created this logical data type. B evaluates to true logically. Okay, so the last one that I'll cover in this video, straightforward pretty much. Character variables, strings, text variables. They're contained within in quotes. They can be double quotes like this or single quotes. I'm going to create an object called C, and what I'm going to do is assign that one element, which is the string hello world. Okay, so if I run that, you can see C it appears in our environment as hello world, and if we ask for the class and data type of C, they're both shown as character. Okay, so that's it. That's all I'm going to cover in this video. Just kind of a little bit more basic stuff on data types in R. The most common ones you're going to encounter are numeric, integers, logical, complex numbers, and characters. There is another data type, I chose not to cover it here, which is something called a raw data type. And this is you're unlikely to be using it, working with it until probably, unless you're doing kind of more advanced stuff in R. But it kind of allows you to save and work with data at the byte level. So it allows you to kind of like these low-level operations on binary data. I don't think anyone's immediately going to be doing that if they're kind of doing introductory R stuff. But the key ones to know about are your kind of your numeric or double precision real numbers, your decimal numbers, your integers, logical statements, logical data types, complex numbers, probably less frequently used, characters, text, string variables, certainly something that would be used a lot. Okay, that's all I'm going to cover in this video. Next video, I might go on and talk about how to import data in different formats. So that's probably, if you want to do data analysis in a programming language like R, using something like RStudio, you've probably got your own data that you want to analyze. So we'll talk about how to import different data sets that are saved as in different formats, and then we'll kind of move on from there to talking about how you then tidy up your data sets and kind of explore them visually using different graphing and creation of figures. Okay, thanks for listening. I hope this was helpful.